Ja, då har vi en härlig eftermiddag att se fram emot. Och vi ska börja med att välkomna professor Fredrik Åhs upp på scenen. Från institutionen Psykologi och socialt arbete.
Tack. Hej allihopa. Kul att vara här. I think I will continue in English just so everybody will understand what I'm saying. Although I have prepared my slides in Swedish. So if you don't understand English, you can read the slides. I'm very happy to be here today in Sundsvall, not in Östersund. It's actually the first time I am down in Sundsvall at this campus. Although I have been many times to Hudiksvall, which is just a few kilometers south of Sundsvall. My father is from Hudiksvall, so I've been there several times visiting my grandparents. Hudiksvall is a very nice town, but then my father left anyway to go study in Uppsala, at Uppsala University, and there he found my mom. And they moved to Stockholm, and I grew up a little bit outside of Stockholm in a suburb called Kälvesta. In Kälvesta, I often at night felt very afraid because I thought there would come soldiers and that there would be a war. So I slept with a knife under my bed because I thought the knife could protect me against the soldiers. And why I was afraid of war was because I had watched the news on television. At that time, we had two channels in Sweden. There was Channel 1 and TV2. And there was a war in Iran and Iraq. And often they broadcasted pictures from these wars. And it made me feel afraid. So when I laid in my bed and thought about these soldiers, I thought it seemed pretty realistic that they could come also to Kälvesta. But after some time, I got used to the idea of soldiers. It didn't feel so frightening anymore. There was never any soldiers coming. But then one Saturday morning, when I sat in a blue armchair in my living room, talking to my grandpa from Hudiksvall, who always called us at 9 o'clock in the morning, every Saturday. I watched out over the window across the backyard and saw a plane coming very, very close to the treetops. It was making a huge sound. And then it went down and crashed. And this is where it crashed. And it was just lucky nobody on the ground got killed here. It was children out playing. It crashed on a parking lot, but the children went inside to watch television at 9 o'clock, and fortunately they weren't there then. After this accident, I was afraid of planes crashing in our house, and I again had trouble sleeping. But after some time, when no planes crashed in our house, I realized that this is probably not going to happen, and I could sleep safely again. Both these examples are examples of learned fear, or how I learned to associate something that I didn't know about before I had watched on television that there were wars. And I didn't know that planes could crash before I had watched planes actually crash. But after that, I came to associate these two pictures in my head with aversive feelings. And this is something that we call associative memories. And a way to study these memories in psychology is fear conditioning. And my research is about brain systems that allow us to process fear. And we know a lot about how the brain processes fear from studies in mice and other rodents, where we have used a fear conditioning paradigm. And I'll just briefly explain what fear conditioning is. So here you see a mouse that hears a sound, and the sound predicts that the mouse is going to get a mild electric shock. And after a few pairings, the mouse learns to predict the shock from just hearing the sound. So now when the mouse hears the sound, it's going to react with defensive reactions to the sound alone. From these studies, we have learned about nuclei in the medial temporal lobe, a set of nuclei called the amygdala. And we know that these nuclei are important for learning the association between the previously neutral stimulus, the tone, that becomes a danger signal because it signals the dangerous shock here. So during my postdoc at Duke University, we performed a fear conditioning study in humans using functional MRI, which is a brain imaging technique, to see if this was true also in humans, that the amygdala is active when we learn to form fear associations. And in this study, we found that the amygdala was active. And this tells us that maybe the amygdala is an important part of the fear system in the brain that can teach us how to acquire new fears. And maybe the amygdala is important for understanding anxiety disorders, where we can have acquired new fears to very strong fears. But fear conditioning is not only good to understand how we acquire fears, it's also an interesting experimental paradigm to understand how we diminish fears. And this could be interesting for understanding how we can understand what happens in the brain during exposure therapy when psychological treatment of anxiety disorders. And during fear extinction, we play this sound that previously was associated with a shock without giving a shock. And after a while, the animal learns that the sound is now safe again. It's no longer dangerous. So a little bit in the examples that I told you about my childhood, after hearing these planes never crashing in our house, I learned that the sound of a plane is not dangerous anymore. So this is an interesting analog to exposure therapy or psychological therapy. And in the continuation of this experiment that I just showed you, we found that the inhibition of fear or the extinction of fear depends not only on the amygdala, but also on a series of brain regions here called the hippocampus, which is known for its importance for memory. And the hippocampus signals to the medial prefrontal cortex that in turn seems to signal to the amygdala that it's no longer dangerous. Now it's safe. So this is all very well, but is this really an analog to how exposure therapy works? To understand how exposure therapy works, we have to study patients who actually have naturally occurring fears, such as social phobia. Social phobia is one of the most common types of phobias, and it can be very handicapping or have a large impact on people's life because it limits what you think you can do. And in this experiment, we let people who had social phobia perform a speech which they think is extremely distressful twice. And we looked at what brain regions change their activity when they do this repeatedly and also feel less anxious, because most people who performed the speech the second time, they felt less anxious than the first time. And we found reductions in the activity in the amygdala. And then we looked at another group of people who had spider phobia and let them watch pictures of spiders repeatedly, and saw that the more pictures they watched, the less afraid they felt. And here again, we found that there was a reduction in amygdala reactivity. And in this graph here, you see the early and late trials, and you see the amygdala activity on the y-axis. And the top line here is, you can see that the amygdala activity drops from early to late trials. So in both these types of phobias, what seemed to be a common denominator here was reductions in amygdala reactivity as a function of treatment. But we did not see any change in activity in the hippocampus or the ventromedial prefrontal cortex that I showed you were important for reductions in learned fear. So this made us think that maybe it's not all about learned fear to understand the neurobiology of social phobia and spider phobia. Maybe it's something else. Maybe it's a type of innate fear. So then we started to think, how can we study innate fears in the general population? And this is one type of fear that protects us against objects that pop up near the body. And this is just to show you that you don't have to learn this. Even babies are afraid when this jack-in-the-box pops up. You can see the reaction on the face of this kid. It's not funny until after a few times, maybe when you realize that you can predict what's going to happen. So this first study is just to show you that if we measure a defensive response called startle, this response increases with the proximity of an avatar that you see in this case in virtual reality headset. So distance seems to be predictive of defensive responses, which you could guess. And this is, of course, an innate type of response. So then we went on to study what happens in the brain when you see things showing up within your personal space. And again, we saw that the amygdala increased in activity. As you can see on the left picture here, here you see the brain from above. But also, which is interesting, so a part of the brain called the lateral geniculate nucleus, which is one of the first regions in the brain to receive information from the eyes. So it's a very early processing stage of visual information in the brain. And it makes sense somehow that if a fear is innate, that it should be implemented at a very early stage in the visual processing stream. And this seems to be the case. We also found lots of activation in visual areas here in the back of the brain, in the occipital lobe. We did this study in twins. So we have information on both on monozygotic twins or identical twins that come from the same egg, same sperm. So they share all the genetic information in between them. And from fraternal twins who share only half of the genetic information because they come from two different eggs. And by doing this experiment in these twins, we can draw inferences about how much is the genetic influence on this brain activity. And we found that in primary visual areas, there was a genetic influence. And this means that fear processing in the brain could be genetically influenced so that it could maybe predate anxiety. So while anxiety can run in families and can be transmitted over generations, could be because of how the brain processes different types of fears. So when Per Lagerkvist, who is a Swedish author, said that ångest is vår arvedel, we here show that this could be implemented at the level of the brain. Anxiety is my heritage, he meant by that. All right, thank you.
Ja, tack så mycket för intressant ämne och område naturligtvis. Hur har vi det med frågor? Funderingar?
Ja.
Thank you so much for your interesting presentation. I'm just asking this out of curiosity, and it has to do with a feeling I have prior to a presentation. Mm-hmm. When you attend conferences, that gut feeling that strikes you before you present yourself. How does one get used? Because we are exposed to this, you know, quite often, but one never gets used to it.
Yeah.
Can you explain?
Well, I'm just guessing what my approach to this is, or my perspective is an evolutionary perspective. And in terms of evolution, if you're exposing yourself to a crowd, that might be dangerous because the crowd might reject you. And being rejected from a society, of course, could be deadly if you're outside. And therefore, it is adaptive not to put you in that situation because it could lead to negative consequences. That's what I would think, but I'm not sure. But it is also that with practice you get less and less anxious, and also with age. Maybe not everybody, but most people. Not you. You seem very brave.
Ja, vi får tacka Fredrik med en stor applåd och en liten present.
Tack så mycket. Tackar.